A shrink packaging line can produce one attractive package and still fail the conditions that matter in production. For a 35 kilowatts door panel line, acceptance must establish more than power-up, conveyor movement, and a successful sample cycle. Heat, electrical controls, moving equipment, sealing, and surface-sensitive products all create operating risks that may not appear until installation. Factory acceptance testing converts those risks into observed evidence. The objective is to confirm that the agreed configuration performs with representative samples, that critical safety functions respond as expected, that unresolved issues are recorded, and that the buyer receives the information required for installation and operation. A startup demonstration is only one part of that process. Testing should also cover different door and panel configurations, realistic settings, planned utilities, normal and abnormal stops, restart behavior, cooling, and final transfer. The sample set should extend beyond a flat standard door. Glazed doors, thick decorative panels, raised edges, wide laminated boards, and other agreed boundary products can reveal problems with film presentation, tunnel behavior, roller contact, guide clearance, and discharge stability. The purpose is not to test every possible catalog item. It is to challenge the limits that will govern real production decisions. Before the test begins, the scope should identify the delivered equipment configuration, included conveyors, accessories, electrical and pneumatic conditions, product samples, appearance criteria, test sequence, safety demonstrations, required documents, and nonconformity process. Each result should have a defined status. Pass with a documented condition, retest required, or site acceptance verification required. Appearance criteria must be concrete. Inspection can address film coverage, seal integrity, loose edges, wrinkle severity, exposed corners, contact marks, surface cleanliness, and package condition after cooling and transfer. The inspection method, timing, and responsible signatories should be agreed in advance. Utilities should also be recorded exactly as used during the test, together with assumptions about the buyer's electrical supply, compressed air, ventilation, upstream timing, unloading space, and material flow. A disciplined FAT can be organized through 6 evidence gates. The first verifies safe control, including emergency stop, guard condition, isolation information, and controlled restart. The second examines product movement, detection, entry orientation, conveyor stability, transfer, and unloading. The third evaluates film feed, coverage, sealing, and edge condition. The fourth inspects shrinking, side pressure, cooling, and final package appearance. The fifth addresses maintainability, including access, cleaning, routine checks, consumables, and parts. The sixth confirms handover evidence such as manuals, drawings, settings, test results, and responsibilities. Critical safety conditions are pass or hold decisions. An emergency stop that does not create the expected safe condition, inadequate guarding, an unsafe isolation path, or uncontrolled hazardous movement cannot be offset by good package appearance. These issues require correction and redemonstration. Other findings can be managed through a risk tier process. Unstable transfer, seal failure, loose package edges, and repeated surface defects require corrective action and another relevant sample test. Unclear settings, inconsistent appearance, or incomplete operating records need documented owners and verification before final handover or site acceptance. Minor labeling and documentation issues can carry an assigned owner and closure date, provided they have no operating effect. When defects recur, the record should capture film type and condition, product dimensions and orientation, conveyor speed, tunnel setting, side roller position, cooling time, and the point where the defect first appeared. That information supports a root cause investigation and prevents a retest from changing several variables without establishing what solved the problem. For a product such as the PLC-controlled SWDP01 door panel shrink wrapping machine, stated power, controls, utilities, film range, adjustable conveyor, detection, sealing blade, tunnel, and side rollers can each become an observable FAT test. The final decision should remain tied to the tested configuration, representative samples, and documented evidence. Acceptance is justified when safety, movement, package quality, maintainability, and handover records are verified, with every remaining site condition clearly assigned for closure.